Assalamualaikum. I am Muhammad Hazim bin Zaid Ali. I'm going to start my part of presentation on introduction. Banana plant is the high herb that comes in a variety of sizes, colors and flavors depending on the size, color and flavor of the bananas reproduced. Additionally, it supplies us with numerous polymers such as cellulose, hemicellulose, pectin and lignin, which offer fibers with high mechanical qualities. Unfortunately, these precious materials are not being fully utilized, as the huge quantity of fibrous material generated from its leaves and stem are being thrown out as waste. Therefore, this project demonstrated that paper production using banana stems is proven to yield economic and environmental bonuses as an alternative. Furthermore, this project aims to produce paper using the banana stem by applying the kraft pulping method. The significance of this project is that it can be the exact solution to overcome excess banana stem waste not being utilized when this project is promoted to the public. Other than that, it can offer income source opportunity to society such as farmers who manage banana plantation. We will now go through our project's results and discussions. The papers that we successfully produced can be seen as shown in the picture separated into two phases of production. In the first phase of production, 40 grams of pulp weight from each. The papers obtained are thick, hard and have rough surface. For the second phase of production, 20 grams of pulp from each weight and the papers obtained are thinner, softer and have smoother surface. However, Nipah B wasn't able to be produced due to insufficient time and raw materials. Other than that, we retrieved a sample from commercial paper bag as a standard to compare with the results from the test on the papers we produced. The absorbency analysis helps to measure the amount of water the papers can absorb or resist in a set period of time, specifically in this case, is for 1 minute. The water absorbency of the papers strongly influences their printability. Table 1 presents the data obtained for dry weight, wet weight and mass of water absorbed of those samples. From Table 1, commercial paper bag sample had a dry weight of 0.347 grams before the test and had a wet weight of 0.672 grams after the test had been conducted on it. Then, through calculation, the mass of water absorbed is 0.325 grams. With this data, it can be said that the sample with the least amount of water absorbed after the test is the best, which can be clearly seen from the table above, it being the sample from Nangka A. Residual non-combustible matter after incineration or burning is referred as ash. In most cases, the ash content of paper will contain inorganic residues from the pulp, inorganic residues from papermaking chemicals, and loading of filling materials deliberately added. Table 2 presents the data obtained for net dry weight, combusted weight, loss in weight, and ash content of the samples. From Table 2, ash content in the commercial paper bag was as low as 2.06%. Therefore, based on the data obtained from the other samples, it can be concluded that Kapas B is the best, as it had basically the same value of ash content as the standard and even lower, which is 1.96%. In this experiment, there are no loading of filling materials added during the production of paper. Therefore, the most likely case is that the ash content refers to inorganic residues from the pulp or inorganic residues from papermaking chemicals, and as mentioned, paper with the least ash content is Kapas B. Moisture content can be defined as the amount of water in a material or substance. The moisture content of paper also affects its various mechanical, surface and electrical properties and contributes to the qualities of printability and runnability in the various printing processes. Uniform moisture content is critical for paper to be free from distortions such as curl, twist and waviness, which cause printers and copiers to jam. Table 3 presents the data obtained for wet weight, dry weight and moisture content of the samples. From Table 3, moisture content in the commercial paper bag was 6.58%. Through the samples tested, the one closest to the standard is Kapas B, which is 6.79%. Kapas B is proven to be the most suitable for printing works for the same reason mentioned. To conclude, Nangka A is the best in terms of absorbency, while Kapas B is the best in terms of ash content and moisture content. Therefore, it can be said that Kapas B is the best overall, as it concurs the two aforementioned aspects of analysis, while also being the third best in terms of absorbency, which is not that far from the standard. For the paper production, the best amount of pulp required might be between 20 grams and 40 grams. This can be seen most probable as the papers in first phase production are thick and hard but do not have any holes in them. On the other hand, the ones from the second phase production are thin and softer but have holes in them. Therefore, the suggestion on the best amount of pulp to be used is 25 to 30 grams. The flaws that papers in both first and second phase production possess made it impossible for the kraft paper bag production. Hence, with the suggested amount of pulp, it is speculated that the ideal paper bag can be produced as initially proposed.
Conclusion: capacity produce the best quality paper as in conquer edge content and moisture content with the third best in absorbency. The paper in the first phase production are thick and hard but do not have any hole in them. The second phase production are thinner and softer but have hole in them. Therefore, the suggestion on the best amount of the pulp to be used is 25 until 30 gram.
That's all from our group. Thank you.